One of the most common problems people encounter with databases is performance, especially at scale. CockroachDB is a horizontally scalable database, and as a result, it can eliminate a lot of the resource contention that plagues other databases. However, in many cases, performance issues have little to do with scalability. One of the most detrimental operations you can do on a database is a full table scan. In this case, you're running a query that must look at every row in the table in order to find the records you're interested in. For a small database, say tens or hundreds of rows, this might not be noticeable. But as the data set grows, these table scans can dramatically impact performance. Table scans are typically avoided through the use of an index. By default, every table has an index on its primary key. This makes searching for that primary key a very fast operation, but sometimes we want to search for something other than the primary key. For example, in the previous exercise, we did a search by serial number. That's a non-indexed field, and on a large table, it would have probably resulted in a full table scan. In a real database with thousands of vehicles, that could have been very, very slow. So in this exercise, we'll take a look at how to create a simple index in order to improve the speed of certain queries on your data. So the first thing we're going to do is we're going to jump over into our CockroachDB terminal, and we're going to write a very simple query. So I'm going to do a quick query, which is going to look at all vehicles that are of type skateboard, where the make is equal to street slider and the model is equal to motherboard. Now, I'm not actually going to execute this, but I want to actually point out that this is actually doing probably a non-indexed query. And the reason that I say that is because we haven't created any indexes. We are looking for vehicle type, make, and model, and none of those is the primary key for this table. Remember, the primary key is vehicle ID. So that means that if I do an explain on this and hit enter, you'll see that we actually get a full scan, and you'll also see that it's hitting the vehicle's primary index. So it's trying to use the primary index, but because we're not searching on anything in the primary index, it has to scan every record. So we get a full scan. The estimated row count tells us how many rows it scanned. We've only got a small number of rows in the table, so the estimated row count is only 5, so that's not a big deal. But if this was, say, 10,000 rows in the table or 100,000 rows in the table, this would start to become a significantly more expensive operation. Over in my code window, I'm going to open up createindex.sql, and I'm going to write a simple index. So we want create index on mover vehicles, and then we need a list of fields we want to create the index on. So I want vehicle, type, make, and model. Now the order here is somewhat important. We can actually do a query using any of these fields in any order, except that we have to always include the previous field. So if we want to query for just vehicle type, that's fine because there's no previous field. But if we want to query for the make, then we also need to include the vehicle type because that's the previous field. If we want to query for model, then we need to include make and vehicle type in order to actually have it use the index. And so the order matters here, and the exact fields that we include matter. If you wanted to query on each of these individually without including any of the previous fields, then you'd want to create 3 separate indexes, one for vehicle type, one for make, and one for model. Okay, I've run my tests and you can see that they all passed. You're welcome to take a look in detail at what exactly we're testing, but essentially we're testing that a specific set of fields exists. So for example, the vehicle type exists in the index and that it's ascending. I won't go into all of the details, but you're welcome to take a look at exactly what it's testing for. So now that we've done that, let's actually execute our statement in our CockroachDB terminal. So I'm going to go ahead and create that index. That'll just take a moment. And then what I can do is I can actually do my explain a second time, and we'll see what the difference is. So you can see from my results that the table has changed. It's no longer checking the primary index, it's checking my new index, which it's given a name to. And then if you look at the spans, it's no longer doing a full scan. Instead, it's checking a portion of the database records. And then the other thing too is that the estimated row count has gone down. It's no longer every row. It's actually an estimated row count of 0. So the point is that it looks like our index has worked and it has improved potentially our select statement.